Hi guys, welcome back. We're going to cover section B today of chapter 15, and we're going to talk more about heat. Okay, so like I mentioned in the last video, heat by definition is the movement of thermal energy from a warmer temperature to a cooler temperature. Okay, you'll get a chance to do this in class, but if you hold ice in your hand, what's happening is the thermal energy from your hand is actually moving into the ice. That's why the ice melts. Now, your hand feels cold, but that's not the coldness of the ice moving into your hand. It's the thermal energy of your hand moving away. And so your hand feels cooler because the energy moved away. Okay. In addition to knowing the like specific boiling point and melting point of a lot of pure substances in chemistry, we also measure something called specific heat. And this is the energy required to raise the temperature of 1 gram of a specific substance by 1 degree Celsius. And this is a known amount for pure substances. You can look this up and figure out what that is. And what it tells us is that not everything heats up the same. Some things require a lot more energy in order to get them to heat up, okay? And so that's known as specific heat. And it is measured by something called a calorimeter. And we're not going to really do that. It's a little more complicated. It takes fancy, equipment, but it's kind of like this isolated thing that measures the movement of that thermal energy. But notice the root word there, calorie, okay? So calorie with a little c is a measurement that tells us how much energy is required to heat 1 gram of water by 1 degree. So it's related to the specific heat of water, okay? A calorie with a big C is what we measure food in. And that's a measurement of how much energy is in food. The more calories there are in something, the more energy it can release into your bodies when you eat it. There are more usable calories than others. We're not going to get into that, okay? But that's all related to this idea of heat, okay? Heat can be transferred in different ways. And we talked about this in 6th grade. I don't know if you remember it or not, though. So let's kind of refresh our memories here. Conduction is the transfer of thermal energy through direct contact. Okay, so if this is a metal pot and this handle is metal, the heat is going to transfer through the metal into the pot itself, or the hot water into the metal itself, and through that direct contact, it's going to transfer into your hand and you're going to burn yourself. That's conduction. Things need to touch for conduction. Radiation is the transfer of thermal energy without contact. Okay, so when you hold your hands over a flame, you can feel the heat without touching it. That's the transfer without direct contact, and that heat is actually transferred. That thermal energy is transferred through electromagnetic waves. This is how we feel the heat of the sun. Okay, the heat of the sun travels through space. There's no particles of matter in space. And so you can't transfer the energy through all these particles that are in contact with each other. It has to be able to transfer by radiation, okay? And the last one, which is my favorite, and I'll show you some demos on this, is convection. And that's the transfer of energy through fluids. This is why we say things like hot air rises, okay? So what happens is when something gets warmer, a fluid gets warmer, a liquid or a gas, it spreads out, it becomes less dense. And so the less dense things will float and then cause the colder, more dense water to sink, okay? So you can see with this pot of water here, the water on the bottom is going to heat up first. So it's going to warm up, which means it's going to rise because it's becoming less dense. That's going to push this cooler air down. It's going to sink because it's more dense, but then that allows it to heat up. And so it actually causes the water to move a little bit, okay? This is why the tectonic plates of the Earth move, because of giant convection currents in the mantle of the Earth. Okay, this is also why there's wind and all kinds of things like that. These moving currents through fluid is kind of a big deal. And then we get different types of material related to this. So we've got a conductor, which is a material that allows heat to, or allows thermal energy to move through it easily, or electricity. We'll talk about this when we talk about electricity again. Most metals are very good conductors, okay? You don't want to touch a pan that has a metal handle because it will be hot. Most pots and pans have plastic handles or some other material that are insulators, because an insulator does not allow that thermal energy to pass as easily, and so it doesn't feel hot and you can touch it without burning yourself. This is why we cook with wooden spoons. You can keep a wooden spoon in the hot pot and it won't burn you when you touch it. If you stir food with a metal spoon and you keep it in there, you might burn yourself. Plastic is also an insulator, but if plastic gets too hot, it melts itself, okay? So just some basic vocab there. All right, so we get a lot of different vocab within the changes of state, okay? So as thermal energy is increasing, the movement of the particles, the speed of the particles is also increasing, okay? And this is what allows us to go from a solid to a liquid to a gas, okay? And you can see in this picture, solid, the particles are nice and still and close together. This is a gas, those little arrows are indicating they're moving, and then this is a liquid in the middle, it's kind of in between, okay? You should pause this video and kind of look at that diagram because it gives you a ton of vocabulary, and I'm not going to write it down. But very quickly, melting is going from a solid to a liquid, duh. Evaporation is an example of going from a liquid to a gas. I actually like the word vaporization better. And evaporation is just an example of that. So is boiling, okay? But that's when a liquid goes to a gas. Condensation is when a gas, like water vapor, turns back into a liquid, and then freezing is when a liquid turns into a solid. But then we get these two that skip states. Deposition is a gas skipping the liquid phase and going straight to a solid, and sublimation is a solid skipping liquid again and going straight to a gas, okay? But notice what's happening to the thermal energy. As we move from a solid to a liquid to a gas, the thermal energy of the particles is increasing. It requires energy being put into it in order for that to happen, which we can kind of think of as temperature. If I've got ice cream and it gets too hot, it's going to melt, okay? That's thermal energy going into it. If I've got an ice cube, same idea, okay? This direction is opposite. This is decreasing that thermal energy, okay? That's going to decrease the kinetic energy of those particles. They're not going to move as much. They're cooling down. They're getting colder, okay? And you can kind of see this relationship between temperature and heat. Better to think of it as thermal energy, okay? So as temperature goes up and thermal energy increases, we also go from that solid to a liquid to a gas state, okay? And this would be for water. So you've got the boiling point of water right here, which is that separation between a vapor or a liquid, okay? And then the melting point would be the separation between melting and freezing. Now, it's interesting to note that the freezing point of water is 0 degrees Celsius, but it depends on what's happening to the thermal energy. If the thermal energy is increasing at 0 degrees, that means it's going to be melting. If the thermal energy is decreasing and it's still at 0 degrees, that means it's going to be freezing. So both things can happen right at 0 degrees, just like both of these can happen at 100 degrees. It depends on if you're increasing that thermal energy or that temperature or decreasing it. But the changes in state happen at the exact same temperature, okay? All I got. Bye-bye.